Welcome back to day 2 of Intel Vision 2022 here in Dallas, Texas. We've got another fantastic lineup of keynotes, business insights, demos, special guests, and more. Right now, it's time for CTO Greg Lavender's opening keynote. Let's get to it.
So, your morning wake up is connected to your morning wake up, which is also connected to your morning workout. Nice. And to your smart speakers, and your Wi-Fi, and your 5G. It's all so convenient that you don't even think about it, right? But is it secure? Do those things even have to be secure? Nobody would want to hack your coffee machine, or your alarm clock, or your doorbell, right? It's not like anybody would want to hack your fish tank. Who even thinks about those things? Actually, we do. Because your EV is connected to your phone, and to your bank account. And your phone connects to the network at work, which accesses the servers, because your business is operating in the cloud. When you do all those amazing things, somebody needs to make sure that the flow of all that data across the hardware and software, all the stuff that connects the things that make life seamless, is secure. Because innovations like AI and cloud computing will enable an unprecedented level of automation, insights, and capabilities. And every amazing new connection creates a dangerous new potential for data attack from the outside. What you need is protection where it all starts. Security at the foundation of computing. And only one company is at the center of all that data. One that knows you can't begin to be safe without the right hardware and software. Because security begins with Intel. And from a security standpoint, that's really very amazing.
Please welcome Greg Lavender.
All right. Welcome, Intel Vision. I want to thank Pat for letting me out of my Faraday cage to come talk to all of you. Actually, Michael Faraday is one of my great scientific heroes. He's a great experimentalist, had great intuition, discovered the electromagnetic field, and for the last 200 years, we've all benefited from it. So it's a privilege for me to be working at Intel and as a software guy captured in the electromagnetic field of hardware. Hardware and software together is really what's going to make the world better. So it's so good to be here with you in person, and welcome to everyone joining us virtually. It's my privilege to kick off day 2, and I'm going to talk about a number of technical topics, but I'm not going to go so deep on them, given the audience, but I will give you enough technical depth to appreciate what's going on. As you know, as we've all talked about, the last 2 years have been a catalyst for innovation and technology adoption, enabling us to navigate extreme uncertainty while remaining connected for the most part. Occasionally my Wi-Fi fails. But during yesterday's keynote, you heard from Pat and my colleagues about the ways in which we've all adapted and innovation is unleashed across vertical markets as a result of this rapid digital transformation we're all experiencing. But every innovation brings its own set of new challenges. It is true that the seamless integration of technology into our lives is allowing us to do more than ever, but at the same time, it's creating an attack surface and attack vectors at a scale that we have never seen before. So let me start by setting the overall environment that we're all facing and share with you some of the work Intel is doing now and in the future to mitigate the risk. It's not just the threat of attacks, but the actual exploits that are increasing. Cybersecurity Ventures predicts that organizations will face a new ransomware attack every 2 seconds by 2031, up from 11 seconds last year. We are unfortunately at a point where today's attacks can access pay-per-use malware without ever having to write any code. Talk about low code. And the proliferation and threats is just as relentless as the pace of innovation, which is why we design and engineer all of our products and services with security in mind, even doing our own ethical hacking of our own products. The internal hacking and external research provides a predictable quarterly cadence of security updates as part of our Intel platform update. We just announced one this week, and the others were found by ethical hackers working with us, and we even pay them a bounty. These mitigations and security improvements give our customers, you, a higher level of protection against evolving threats. As a result, we deliver an impressive range of security capabilities across an unmatched portfolio from cloud to edge to client. We understand businesses have more technology than ever to manage as they support remote workforces, a multitude of devices, and uninterrupted access and collaboration. Intel has the same challenges. We've all gone through the same things. We all operate in and depend on the cloud. Technology solutions therefore need to secure data not only at rest and in transit, but also in use in RAM. Protecting valuable assets and minimizing those attack surfaces both in and out of our control is critical. I have been a very demanding customer of Intel for decades and understand the challenges all of us face as an industry. It's not only security everywhere, but intelligence everywhere, as AI propels new technology even further, enabling insights and automation to handle complex tasks and greater complexity of those tasks at scale. It is important to develop AI that is both secure and responsible, but perhaps even more importantly, and as Pat mentioned yesterday, it is imperative that the outcomes augment the work done by humans and are used as a force for good in technology. Soon, we will all enter the era of quantum computing. We read about it in the papers. We know this is all present. This will present us with a new set of opportunities to solve complex problems out of reach of today's largest computers, like we heard about yesterday with sort of exascale and zettascale. At the same time, we recognize the startling possibility of a quantum computer breaking advanced encryption methods in mere seconds. That is why security technologies must accommodate and evolve, not just to meet the needs of today, but tomorrow as well. It's why security underpins everything we do at Intel, the only hardware and software company with the breadth and the depth of expertise and technology to support your businesses. I have spent my entire career working on security concerns. They remain an issue that presents an incredible opportunity for our industry to come together and solve, and we'll talk about that. Security and protection of our digital assets is an existential and growing concern requiring the industry's concerted attention, and today I will spend some time talking about three key topics. First, confidential computing and something we call trust as a service. Second, secure and responsible AI with security. Third, preparing today's digital environments in anticipation of the new quantum computing era. And after which I'll be joined by some industry luminaries to share their perspectives on my panel. To meet the cloud computing demands of today's businesses, Intel has a suite of technologies that make it the trusted choice for delivering a secure computing environment. We continue to work on the new technologies with a focus on growing and adapting relentlessly, advancing security across our entire product lines, from accelerating cryptography, hardware-based confidential computing, to safeguarding our supply chain, our manufacturing operations in our fabs, and Intel will never stop innovating in this critical area of technology for all of us. No product or technology today can be guaranteed to be absolutely secure. We all know that. Intel security technologies are hardware enforced and provide a root of trust for securing workloads and limiting those attack surfaces I talked about. In our client portfolio today, we are leading the industry with Intel threat detection technology, known as Intel TDT. It's in your laptop if you have an Intel laptop today, and you may not even know it. You're probably using it. This technology equips endpoint detection and response solutions with silicon-enabled CPU heuristics combined with innovative AI algorithm techniques operating inside the kernel of the operating system to detect malware signatures. Today, this technology helps identify malware and improves the efficacy of endpoint detection and responsiveness in solutions including ConnectWise, Fidelis Cybersecurity, and the popular Microsoft Defender for endpoint protection, among others. We developed and published the spec for Intel control floor enforcement technology that protects against runtime code execution stack hack attacks, first introduced in the 11th generation Intel Core platform. This technology is designed to protect against the misuse of legitimate code that is a technique widely used in malware to hijack it, which is a challenge to mitigate with software alone. As part of Intel's Security First pledge, the CPU-level security enhancements help protect businesses against common malware attacks. Now, let's take a closer look at this idea of confidential computing. It's a topic that's gaining momentum and discussion, more and more coverage in the press. Cloud and edge computing, pervasive connectivity, and demand for AI everywhere drives ubiquitous computing in this environment where security of customer intellectual property, privacy, data, code is paramount, driving the need for that level of confidentiality and protection of computing assets broadly. So in today's information economy, organizations use encryption technology to protect data at rest data in transit. However, there's a gap in protecting data, exposing your service data to the rest of the system. To address this gap, confidential computing has emerged as a new form of computing that protects in-use, in-memory by performing computation in a hardware-based trusted execution environment, also known as the TEE. Using Intel's software guard extensions, also known as SGX, is the proven trusted execution environment technology powering confidential computing today in private, public, and edge cloud environments. Intel confidential computing technologies provide protection for sensitive data and applications, isolating applications from one another, even in the cloud, and the operator in shared platforms doesn't have access either. This protects the application from malicious threats posed by insiders as well as applications in the cloud. Today, Intel Xeon processors support confidential computing in the cloud, in virtualized environments, as well as bare metal through the application isolation features of the secure enclaves of SGX. We're also working on a new architectural element to deploy hardware-isolated virtual machines called Intel Trust Domain Extensions, or TDX. And security of TDX will be greatly enhance the usability, data protection, and intellectual property protection for the cloud tenant while helping cloud providers manage resources and platform integrity. And we will not stop innovating in security. We plan to extend confidential computing beyond the CPU to our accelerators, which you heard about yesterday, such as our GPUs, our FPGAs, and our IPUs through software and hardware technologies coming in the future. We can achieve new levels of security and deliver the performance that people expect. In the confidential computing environment, trust is established through a process called attestation. Attestation is a critical process by which an environment, computing environment, is established trustworthiness. Attestation process allows a customer to ensure protection prior to releasing their sensitive mission-critical data and code to be processed in the cloud. It is also a key element of the zero trust approach to verify everything that we all want to achieve. Today, I want to introduce an exciting effort that represents a major step forward in extending attestation services in the cloud, data center, and the edge computing environments to provide unprecedented security. It's called the Intel Software as a Service offering called Project Amber. Project Amber is a trust as a service solution that will provide organizations with independent verification and trustworthiness of customer assets no matter where they run. In this architecture, the attestation authority is no longer linked to the infrastructure provider. This decoupling helps provide objectivity and independence to enhance trust assurance to users and application developers. Project Amber's initial offering will be a cloud-agnostic, multi-cloud, federated service with provable integrity of its verification processes. We are launching a pilot for Project Amber with select customers later this year. For those of you who are here today and would like to learn more about Project Amber, please join the Increasing Trust and Confidential Computing session that will be held right after this keynote. It is so important to have these security innovations I have highlighted that require the hardware and software working together. Our software-first strategy, which I'm driving for the company, is a competitive advantage with investments and contributions over many decades. Over the last 5 years, Intel invested over $250 million in advancing open source software security. As we approach the next phase of the open ecosystem initiatives that Intel is driving, we intend to maintain and grow this commitment to double-digit percentages. Intel's breadth and depth of hardware and software technologies puts us in a unique position for our customers to derive additional value from their existing platforms. This means that the value can be realized from the hardware up through all the layers of the software stack that are layered on top in any environment. The top layer encapsulates what I call market-making technologies built on foundational and middleware software layers, which Intel contributes to significantly. Building on an incredible foundation of commercial and open source software, we can deliver new subscription services and solutions such as Project Amber to meet the growing needs of our customers. The middle layer, which I call market differentiating software, consists of all the large sets of tools, libraries, languages, and frameworks, much of it open source. And the middle layer gives our customers a lot of choice when it comes to the technologies they adopt to realize market value. Intel invests and contributes significantly into the open source software projects guided by our commitment to an open ecosystem approach. And let me share some examples of how we take open source technologies and match it to our confidential computing objectives in hardware. A critical element in the ongoing development of confidential computing is an open source project initiated by Intel called Grameen. Grameen is a library developed by Intel with others contributing across the community that enables a Linux kernel emulator to run unmodified Linux applications in restricted environments called Intel SGX enclaves. And these enclaves is where we use the hardware to secure the application code and data as needed. Grameen makes it easy, almost not quite push button easy, but very easy for developers to deploy confidential computing solutions using SGX's trusted hardware without significant application code modification. Grameen provides a push-button method for easily protecting applications and data. This means a faster, more secure, and more scalable end-to-end security solution with minimal effort, and we have an integrated Project Amber with Grameen for providing the attestation verification of applications that adopt it for confidential computing. This is particularly important in edge computing where models and the data associated with the models are often stolen. At the foundational layer on which much of the world's software runs and represents what I call market-enabling technologies, customers and developers have the assurance of running their applications with industry-leading performance and security because we control that layer in all of our products and we make sure it's secure, signed, and confidentially computed. Confidential computing and the introduction of Project Amber are great examples for how we scale technology up the stack by leveraging the breadth and the depth of Intel's software and hardware technologies. And we can deliver immense value into this ecosystem while reducing risk. It would be impossible for me to talk about the cloud without recognizing AI's contributions to the rise in the amount of data that's being generated and the data workloads and the models that are being executed. The promise of AI and machine learning have paved the path for deployment across verticals, and include healthcare, financial services, manufacturing, retail, entertainment, et cetera. And the proliferation of sensitive information adds to the growing threat landscape, and more importantly, the security and privacy concerns surrounding it. At Intel, we believe in enabling society to make decisions about the responsible use of AI. We are working to provide the security technologies to enforce those decisions. The ethics associated with responsible use of AI also serve as a perfect example of how we can come together to help ensure technology improves the lives of every person on the planet. Our engineers are working on future technologies, are guided by a compass that leads them to answer one question before they decide to continue pursuing development. Does the technology contribute to improving our society? They ask this question during the various stages of technology development to prove its merit. Maintaining data integrity, accuracy, and privacy is always at the heart of Intel's industry-leading research efforts in Intel labs and across the company. I would like to share some of the initiatives Intel is engaging in that are pushing the boundaries of securing AI models while also helping protect the privacy of data and building the infrastructure for responsible deployment of AI. Let us start with the cost of developing AI models, which can range between $100K up to even $10 million. So protecting that intellectual property is a high priority for those users and those applications. Due to data availability, latency, or other requirements, AI models are often run at the edge, which is outside the security perimeter of most organizations. To help those organizations trust the edge environment for AI deployment, we help secure AI models using Intel's OpenVINO machine learning platform. This is combined with a security add-in based on Intel-led open source Grameen and SGX hardware. So let's move now to industries such as healthcare, where regulatory restrictions associated with data privacy complicate the path to reaping the benefits of AI. As part of Intel's commitment to responsible AI, together with security and protection and privacy of data, we partnered with Beekeeper AI to create the first secure healthcare collaboration platform. And Beekeeper AI uses Intel SGX hardware-based security and Microsoft's Azure confidential computing infrastructure to provide a zero-trust platform. Beekeeper AI enables an AI algorithm to compute metrics against multiple real-world clinical data sets without compromising the privacy of the data or the intellectual property. The algorithm allows the user to accelerate the development, deployment, and medical AI innovation by more than 30 to 40% when compared with the current method. This AI security solution is fully compliant with global data regulations. This is a great example of how healthcare can greatly benefit from AI. The convergence of AI and security is essential to address the concerns of privacy and data sharing between institutions to enable responsible AI. Now I'd like to welcome Jason Martin, a principal engineer in Intel Labs, reporting into me, that that's onto the stage to share an example of how Intel technologies are enhancing trust in a very distributed manner. Jason?
Thank you, Greg. Hello, everyone. Science and technology have enabled us to accelerate a number of areas of progress by aiding humans' potential for innovation. And the medical industry has a long history of using technology to improve diagnosis and treatment. For example, the first critical step in planning treatment for a patient with a brain tumor is taking an MRI and locating the tumor in a process called segmentation, which is dependent on the availability of a radiologist. Now, augmenting humans with AI can alleviate pressure on the strained medical system. Intel has a research partnership with the University of Pennsylvania, Perelman School of Medicine's Federated Tumor Segmentation, or FETS initiative, and it's an excellent use case. The FETS initiative uses a set of Intel hardware and open source software technologies to improve the training of AI models to locate brain tumors. Now, due to the nature of the data and patient confidentiality requirements, this data cannot be centralized in the cloud. Instead, we distribute the computation to each of the institutions, where it operates on the local data. Now, the FETS initiative software platform uses a combination of PyTorch with an Intel-developed open source software framework called Open Federated Learning, or OpenFL. OpenFL enabled 55 institutions across 6 continents to collaborate while preserving the security and privacy of their individual data sets, and achieving a higher fidelity inferencing result than was previously possible. The result is an AI model that improves efforts to locate tumors by 33%. Now, Penn is using 3rd-gen Intel Xeon processors with Intel Software Guard extensions to protect these learnings and the resulting algorithm. By bringing data, AI, and our core trusted computing platform together, we can accelerate security across the cloud, to the edge, and the data center, and unlock the potential of our partners. What better way is there to improve people's lives with our technology than helping the medical field save our loved ones? So if you're here in person, please visit our show floor to see a demo of how OpenFL enabled multiple institutions to collaborate and improve tumor location efforts. I will hand it now back to you, Greg, to talk about a use case for AI to address digital media.
Thanks, Jason. Great job. This is what gets me excited every morning when I come to work, is working with folks like Jason and Intel Labs and across the company. So it's really, really exciting initiatives we have here. So in addition to the initiatives that Jason mentioned, we're also investing in addressing deepfakes. We all know this is a problem in social media, okay? And deepfakes are synthetic media created by advanced AI algorithms. Well, I wouldn't call that for good, where the actor, the action of the actor, or the content is manipulated or completely fake. So we all have concerns regarding deepfakes and its impact on our society and our ability to spread misinformation through manipulated content. While AI is being exploited to create deepfakes, we can also use it as part of the solution to prevent them. Fake Catcher is a deep learning solution to detect deepfakes. It utilizes the temporal and spatial characteristics of biological signals that are hidden within the authentic videos. To create a robust detection solution, Intel built the world's first real-time deepfakes detection platform by boosting Fake Catcher with Intel AI optimizations in our OpenVINO AI models. In the immediate battle against deepfakes, AI helps us detect fake media as a longer-term solution. To address the origins of media, Intel has joined forces with the Coalition of Content Provenance and Authenticity, setting new standards and policies to restore trust in our digital content. For those who have joined us in person, today we have a fascinating deepfakes detection demo on the show floor that I encourage you to see. Now, I'd like to turn our attention to the future and talk about quantum computing and post-quantum crypto. Intel sees a future where everything is encrypted, from your shopping cart list to your medical records, everything. And today, data is cryptographically protected, requiring multiple cryptographic operations, which are very compute intensive, and our hardware accelerates them. So, ultimately, quantum computers have the potential to provide computational abilities that traditional computers cannot match, and there's lots of good things about that. However, public key cryptography, serving as the foundation of secure transactions over the internet, could be compromised with quantum computers, and attackers will have the ability to break symmetric crypto algorithms and completely break public key crypto using protection of data once they reach a certain scale and a number of qubits. When can we expect these powerful quantum computers to start posing a serious threat? There's a lot of debate about this, and while it's hard to predict the exact timeline, as quantum technology continues to develop, post-quantum experts are anticipating a moment in the next, say, 10 plus years where we as an industry will reach a similar situation as we saw with, remember, the infamous Y2K millennium bug, which many are now calling Y2Q. And Intel is developing rich cryptographic technology pipeline to lead the industry with innovations that are quantum resistant. But it will require the entire ecosystem, all of you, all of us, all the industry partnering to bring its ingenuity and collaborate to find the solutions if we want to be Y2Q ready or quantum resistant by 2030. Although fully capable quantum computers are not yet available today, adversaries can still pose a threat by harvesting today's encrypted data with lower encryption quality now and decrypting it later when quantum computers are available. When I say this to sort of people I know, they say, well, why do I care? You know, that 10-year-old data is not going to matter to me. I said, well, your social security number is not going to change in the next 10 years, is it? So I can still decrypt and get your social security number and use it effectively. So the time to act is now. So in fact, today's third generation Intel scalable platform, Xeon scalable platform, is the most protected Intel Xeon platform, providing built-in crypto acceleration for next generation security without sacrificing performance. The platform includes instructions coupled with algorithmic and software innovations to deliver breakthrough performance across a host of important cryptographic algorithms in use today. But we do have more work to do to defend against the future quantum adversaries. But post-quantum crypto is based on mathematical problems that are considered difficult even for quantum computers to solve. In the case of symmetric crypto, increasing key sizes is considered sufficient to address what is known as Grover's attack, named after the algorithms he developed. However, public key crypto is expected to be completely broken due to Shor's algorithm, and current crypto algorithms will need to be replaced with a new class of quantum-resistant algorithms currently going through standardization at Nist, the National Institute of Standards and Technology. In fact, one of the representative algorithms is proposed by Intel. Intel is proactively working to address risks posed by quantum computers. We have developed internal quantum crypto guidelines for our products, specifying algorithms and parameters required for increasing resistance to quantum attacks. And Intel is actively contributing to the post-quantum crypto standardization efforts. Our strong commitment to innovation has fueled research investments into these new families of crypto algorithms, and we're developing the building blocks for post-quantum crypto, which will go across all products. We adopted a three-phased approach to address these threats posed by the quantum adversary. First, we addressed the problem of harvesting encrypted data by increasing key sizes, as I mentioned, of cryptographic algorithms, both symmetric and asymmetric, per Nist guidelines. For example, replacing AES 128-bit with AES 256-bit gives us more time and gives you more protection even today. Second, we are increasing the robustness of code signing applications such as authentication of our firmware and software as part of our confidential computing platform with quantum-resistant algorithms. This helps guard against attacks that break classical crypto to run malicious code. Third, we're working to secure the internet by replacing classical public key crypto algorithms with standardized post-quantum crypto algorithms. This includes key encapsulation, digital signature algorithms used in your applications that are fundamental to securing our transactions over the internet. If you're here in person, you can learn more about how Intel is approaching this problem at the Intel Labs hosted session entitled Post-Quantum Crypto after this keynote. So, we have a shared responsibility to protect our critical infrastructure from quantum adversaries. In fact, just last week, President Biden, you may have seen it, announced 2 presidential directives reiterating the urgency of promoting means to address both the opportunities, because they're good opportunities, but also the risks of these quantum technologies. I know you will join us in this journey to accelerate innovation to protect our digital world from the risk of post-quantum crypto attacks, and together as an industry, we will be prepared for the quantum resistant before 2030. We are excited to collaborate with the administration and our ecosystem partners in this mission to advance quantum computing and transition to the secure post-quantum world. The end of this decade will be here before we know it. We are already making the hardware and software investments today to be ready for that eventuality. As we have all seen, demand for computing continues to grow exponentially, and as we all know, security threats will continue to grow exponentially as well, unabated. And security begins with Intel. We will never stop innovating to keep our customers safe from today's constant and evolving threats. As enterprises increase their dependence on the cloud, our encryption technologies and hardware-rooted trust environments help you better secure your sensitive data and applications during execution. This gives business leaders a higher degree of assurance that their data and their code is protected in the cloud. Our introduction of Project Amber today is just one of the many ways that we are delivering on our commitments to enhance security for our digital world. We are the trusted choice for secure computing. We will continue to deliver market-enabling, market-differentiating, and market-making software technologies such as Project Amber to unlock additional value realization at all layers of the hardware and software stack that Intel delivers to the market. Our open ecosystem approach leverages our software and hardware technologies to deliver immense value into the ecosystem to our customers, partners, and market in general. There's an estimated 20 million software developers that every day are using Intel-optimized software from the open source or from the commercial world that they don't even know is optimized for Intel. We do this with transparency, assurance, and an unwavering commitment to ensure that technology is a force for good. Technology helped us leap a decade ahead in the last 2 years. We became globally connected in the face of uncertainties and increasing complexities. The technology ecosystem collaborates through openness, trust, and transparency, and that we can discover what's impossible and actually become what's impossible to make it possible. So together we can innovate at scale to secure our digital futures. I would now like to welcome our distinguished panelists and a moderator for an engaging conversation to get an industry perspective on how we can cooperate to secure our digital future. Please welcome Kim Zetter, an award-winning investigative journalist focused on cybersecurity and author of the book Countdown to Zero Day, as moderator. Jamie Thomas, General Manager for Strategy and Development, IBM Systems, and chairperson of the Open Source Security Foundation Board, which I am on. And my other guest, Mark Ruzinovich from Azure, CTO for Azure Cloud, was also on that board, will be joining us as well. Welcome, my guests. Oops, sorry. Hey, Mark, welcome. Welcome.
Hey, Greg. Thanks for having me.
Welcome. Okay, let's get started. Thank you very much.
Good morning, everyone. Thanks for joining us. We've got a great panel this morning with some of the top minds in the industry. We're going to talk a bit about some of the great strides that the industry has made, long overdue strides, I'd say, over the last few years and is poised to make over the next decade. I want to sort of started off by just to sort of addressing that issue of what has taken so long and why now. It feels like we had more than a decade of talking about the need to address a lot of the real foundational issues in security. And now we are with confidential computing, with more secure hardware, secure enclaves, with addressing the software stack, and particularly more recently in the last year of really looking at the issues with software, open source libraries. So if this is, it feels a bit like this is the golden era of cybersecurity. So what I want to ask the panelists is that a true characterization of where we are now? And if so, really, what has, either in terms of innovation or in terms of cooperation, really what was the tipping point to make it possible now and really to cause this era? Just go ahead, Jamie.
Yeah,
you can start
I'll go ahead and start. Okay, every day at 8:30, my life starts with cyber operations for the IBM company. So that's the way I start my day. And what I would say in the last year and a half is we've seen an unprecedented ramp of the attacks and the sophistication of the attacks. I think we've all been dealing with ransomware. We've been dealing with that situation for quite some time. But with the advent of the SolarWinds attack, it was a very sophisticated software supply chain attack. And then it was followed by the Kaseya attack, and then of course, over the Christmas holiday this past year, the opportunity to have Log4j ruin your holiday, if you will, and have to patch all of this software given the prevalence of Log4j in open source. So really what this means is that it's a new era, and we really do need to cooperate as an industry to apply many of the foundational technologies and techniques that Greg articulated in his speech today. And I think that's what's really encouraging us all to cooperate with OpenSSF and other forums, because we have to. Otherwise, the adversaries will take advantage of this opportunity.
Thanks. Mark, do you think that the government's push behind a lot of this stuff has really had the biggest effect on making sure that this is actually moving forward?
Well, actually, I think a lot of this was in motion for several years before the government really started to get involved more recently. The foundation of the Open Source Security Foundation itself happened about 2 years ago, and it had been in the works for some time as Microsoft and others in the industry like IBM and Intel recognized the growing dependence on open source software and the need for the industry to actually take a role in helping secure it. Because we're all consuming it, we're contributing to it, and so we've got a responsibility to our customers to ensure that what we use and what we contribute is secure. So more recently, the government has had several summits, including one this week on open source security that the Open Source Security Foundation is front and center at. And I think that this represents a new partnership between private sector and industry, public sector and industry for securing it. So we welcome the government's participation, not just the U.S. government, but governments around the world that are more getting involved. But the fact is that this has been an industry-led initiative before the government's got involved. So like I said, I think it's great that the government's helping focus attention on this. From a government supply chain perspective, of course, it's very important as well, but it has been in motion for some time.
Greg, do you want to add anything?
Well, we all remember the OpenSSL Heartbleed, issue that happened. It was a New Year's Eve a few years ago. I was actually CTO to Global Financial at the time, and obviously we patched our perimeter as fast as we could get it. First, we had to find all the places where OpenSSL was positioned. But then it was embedded in every vendor product, firewall products, routers, switching products, and so it took months to actually remediate, the ecosystem, not just protect my web tier defense. And so I think and again, we've all come to rely massively on all this open source software, and so that is an attack surface of vulnerabilities, and there's a lot of incentive to insert malware into it because the governance around it can be somewhat lax in some places. And so we're working through the OpenSSF and with the open source community to drive more, sort of secure open source. And I'm an advocate, and we've been talking about this, of having a central repository of verified, trusted, sort of validated open source software that's not just been security scanned, but sort of attacked, in the way we do at Intel with our Intel ethical hacking. And I think, we have to just as an industry, just stop thinking it's everybody out for themselves. It's really about us being able to come together because the threat is existential for all of us, and that's the opportunity. And we have to do it not just at the hardware layer, which I've talked about, which Azure Cloud, we've worked closely with Azure Cloud and Mark's team on our SDX capability and confidence computing in Azure Cloud, but the entire software ecosystem, infrastructure as a service, platform as a service, containers as a service, software as a service has to be protected. And that's why I talked about Project Grameen and how we can link that protection of the hardware with the software.
Do you think that there's anything that is being overlooked in terms of the projects that are happening now? Perhaps maybe innovations in patch management. Is there something that really is missing from the projects that are in motion?
Well, I think in the world of technology, there's always going to be something that's, quote, missing, but I think it's really critical for us to really deploy and execute on some of the foundational elements that we already know we need to do. We are certainly partnering with the industry and Intel and others on confidential computing, trusted secure boot, and quantum safe algorithms. And I think that executing on those principles alone will make a big impact on the whole full technology stack that we're all using across our on-premise environments as well as in the cloud. I would say that when you see something like Log4j, it's not just about getting those patches out there, it's about the fidelity and the rollout of the patches across the many organizations that have to consume them. And I do know from having tracked the deployment, it can be quite slow. As Greg said, it can take months and months, and that's why cyber operations is also critically important while you're rolling out patches of this type, right, that you have that fabric in place.
Mark, did you want to add something?
Well, yeah, I think you talked about the golden age of cybersecurity, and I firmly believe that. While the threats are getting more sophisticated and coming at us faster, The fact is that security technologies, powered in many cases by the cloud and by artificial intelligence, plus confidential computing and the zero trust progress that we've all made with things like eliminating passwords. I actually don't use a password at Microsoft for my corporate account or my personal accounts, which prevents the phishing vector that is so common, the first entry point for ransomware. But the fact is, when it comes to security, a lot of the basics still matter, including things like password management or elimination, as well as patching, like you mentioned. And this is another place where I think the cloud offers huge opportunities for getting that fundamental in place. Inventory is a key part of it, and then being able to reliably patch through safe deployment processes, what we call in Azure. We're deploying patches to millions of servers every single day for lots of vulnerabilities that are going unexploited, but we're getting into a secure posture for our customers and ourselves on being able to do that. And that is something that cloud technologies are really powering, something that's very difficult to do in a very heterogeneous, non-API driven on-premises world, but something that the cloud, with its API driven nature and with all the signals and telemetry that are collected and then computed on to look at health signals coming off the software and servers as the patch is rolling out, is enabling us to secure our systems very quickly. And this is something that, of course, we're working on making sure that customers can take advantage of on-premises as well as much as possible. But starting with that cloud foundation, I think, is key.
Did you want to add anything, Greg?
We haven't, we're working on this, but we have this capability called seamless firmware updates coming in a future Xeon processors where you can update your systems without rebooting them. You can do firmware updates live. You would still take the apps out of service to do the updates, but just to help speed up this process that Mark is talking about. And those requirements came from the cloud vendors because they have to patch at very large scale, like you said, every day. And so you can't afford to be rebooting all these machines. You have to just do seamless upgrades.
As you mentioned in your talk this morning, Greg, we are moving very swiftly toward a world of quantum computing, Y2Q as you called it. You talked about the year 2030 as being sort of the end point that everyone is sort of looking at. It's only 8 years away, and that's going to hit us very quickly. Do you think that the industry as a whole is taking the steps that it needs to take? I mean, obviously, Intel is making a lot of great strides in this, but across the industry, do you think that everyone is doing what they need to do to address this issue? And what kind of grade would you give the industry right now in terms of addressing this?
I would actually direct that to Jamie, since the IBM quantum computer seems to be in the leading race.
Well, we definitely believe in quantum. We're investing a lot. Just this week, we did announce a 4,000 qubit machine for 2025. So that's our goal, is to have that machine operational. We have a fleet of quantum machines in the cloud today, and about more than 2 billion quantum circuits are executed every day. So we need to take this seriously from a quantum safe perspective. We are contributing to advanced algorithms for quantum safe crypto. We call these crystals, and we definitely urge everyone to take advantage of the deployments that Intel, IBM, and others have made in the processors and in storage devices like tape. Data lives forever, as Greg said earlier today, so you need to take advantage of the quantum safe technologies today, because we at IBM, we do plan to make quantum a reality.
Mark, did you want to add anything?
Well, yeah, Microsoft's also been deeply looking at how to help protect customers against the coming quantum crypto crisis that faces us. And a few things. We're actually trying to contribute to the problem in a sense with our topological qubit approach. We made a major breakthrough with the Majorana Fermion announcement just a couple months ago, where we actually demonstrated one working in process, which is the foundation, we think, for the only approach to scalable quantum computers, meaning getting up into the millions of qubits to solve real-world problems that only quantum computers can address. But we're also working on the defensive side of it as well. We've been working for many years, including in the Nist process, to come up with Nist-approved quantum-proof algorithms or quantum-resistant cryptography. We've got 4 algorithms ourselves that are in the running for the final selections, both in the hashing and signing space. And we've also been working on enabling the use of those algorithms even today with open VPN software that applies quantum cryptographically resistant algorithms to VPN connections. And we're also working across all of our products and services as well as the cloud to make sure that we're ready to deploy new quantum algorithms as soon as that they're approved, something that we call crypto agility.
Greg, did you want to add?
Yeah, no, I tried to frame the problem and to say that, we can't kick the can down the road. And again, we're also working on a quantum computer in Intel Labs, so this is there's lots of effort around this with different approaches. And I think Mark hit the right word, and Jamie said the right word too, which is how do you scale to millions of qubits? That's when we know that we have a real threat. So 4,000 qubits, is in striking distance of cracking current crypto. But as we get to those larger things, lots of good things can come out of it: genomics, medical science advances, et cetera. But our adversaries are also developing their quantum computers, and they may not use them for the same force for good that we're trying to do.
So something that we already have, obviously, in every day is the expanding use of AI. And I wanted to ask you, what in your vision do you consider trusted AI? One of the things that I learned about this morning from Greg was the increasing theft of algorithms and data from systems that are sort of outside the normal perimeter of security. So from the perspective of privacy and security, how are you defining or picturing what is trusted AI, and what are the advances that we've made in addressing that?
Yeah, I think I'd like to use an example. First of all, as Greg indicated, trusted AI is fundamentally important because if you can't believe your AI algorithms and the outcomes, you're not going to get advantage out of them. One example that I would use is just cyber operations. We cannot survive cyber operations without effective layers of AI that we can trust every day. We're looking at billions of events coming in every day. We're instrumenting everything that runs on the multi-cloud environment. So anything that's running on a cloud, whether it's IBM, Azure, Amazon, otherwise, or on-premise, is instrumented. And we have to be able to, in a short period of time, use these AI algorithms to get down to a discrete set of events that we're going to look at 8:30 every morning and decide what action we're going to take. And also, it's important that we anonymize this data. So if someone's doing password equal password, which they do occasionally, on their device or whatever, they're downloading infected software, I don't want to see the name of that individual. I just want to be able to remediate it. So it's just a simple example of security, AI that you can trust, and data privacy in action, if you will.
Mm-hmm. Mark?
Yeah, absolutely. Trusted AI includes responsible AI, it includes explainable AI, it includes the things that Jamie talked about around privacy. And I think that's why I'm personally so excited about the promise of confidential computing. Confidential computing, both from customers being able to kind of protect themselves from access, like Jamie was talking about. We don't want to see confidential or private data of our customers. Confidential computing can help us process that data without making it possible for any of us at Microsoft or in the cloud to see that data. But the place where I really think AI and confidential computing shine is in the example that Greg talked about of Beekeeper. This is multi-party computation, the ability for different parties to bring their data together and to do analytics on top of them to get deeper insights out of it. And this applies in the security space. It applies where consumers are providing their data to merchants, in the advertising space, where today there's a lack of strong controls around how that data is being used and who's seeing that data and who has access to that data, even somebody malicious that can get access to that data. And we see ransomware attacks, for example, that part of the ransomware is extorting a customer with the threat of releasing that data. Confidential computing, again, has this promise of the data can be kept secure at all times where no human can see it, or no human without the authorized access has the ability to see it. And then the multi-party computation aspect of it promises to unlock things in healthcare and finance and government, all sorts of scenarios we're seeing our customers interested in.
Greg?
Yeah, I think Jason, when he gave the open federated learning example of the brain tumor research across 55 institutions, that's a case where they're not loading up these huge image files and passing them around and sharing them. They're doing their training. They're training locally, right? They're getting their parameters. They're doing their parameter model estimation. They're sort of getting their models tuned up. And by doing open federated learning, they're just sort of sharing that training, the results of that training information, and getting a higher fidelity and a better efficacy for fewer false positives, higher true positives in predicting the presence of a brain tumor. And so I think with regard to like bias, right, that was a big problem in responsible AI. By having that open federated training and learning models, I think we can help eliminate and reduce bias in the data as well, because you can detect it because multiple parties are looking at it. So it's like open source training and open source model parameter estimation.
So I wanted to address sort of the challenges that everyone is facing with the rapid digitization of data, and in particular the movement toward the cloud, because there has been this rapid movement to put data and processes in the cloud. And I'm wondering, is security where it needs to be with the cloud? What's being overlooked? And do you find one of the issues being that enterprise customers are relegating too much trust in cloud security? And Jamie and I were talking this morning about, not obviously the enterprise level cloud providers, but a lot of the more smaller cloud providers where customers are sort of trusting what those companies are doing, and perhaps not with legitimate right to trust. So Mark, do you want to take that first?
Well, I think, so like I mentioned earlier, I think cloud is a key part of raising the security bar. The analytics you can perform in the cloud, the consolidation of signals coming from all different sources, including lots of SaaS products and PaaS products and on-premises environments, all going into one place where you can have fusion of signals into getting the high fidelity incident response, as well as the ability to correlate and track attacker movement across these different environments is a key part of it. But I think what you're saying is too much trust in cloud, meaning too much trust in your software supply chain, including the SaaS vendors that might not all be operating at the same level. I think that's where things like the certifications that come with compliance offerings like FedRAMP and SOX can provide some level of insurance. But certainly, I think that if you take a look at the efforts that we're making on open source supply chain, a lot of that applies to closed source supply chain. Almost all of it, if not all of it, applies to closed source supply chain as well. And the federal government is actually not making a distinction when they talk about software bill of materials, for example, between open and closed software. It applies to everything. And I think that this is part of what's going to also raise the bar on security of services that you maybe don't have direct visibility into. But a combination of certifications plus things like software bill of materials, transparency around patch levels are going to make everybody more comfortable and raise the bar for all security in cloud services, I think, as to your question.
Jamie?
Yeah, I think Mark made some very good points. I think with like any provider of IT technology, you should make sure they have the right standards in place and the right protocols, if you will, to provide the data security that you're expecting. I always have this quote, trust but verify as well. And so that's why from a cyber operations perspective, you got to have that fabric in place too to understand what's happening in the environments that are running your business, right? But I think Mark gave a great summary of many of the things we're doing at the OpenSSF and collaboratively across the industry to improve the outcomes here.
Okay.
Yeah, I think, we all know best practices for securing infrastructure, right? And we have monitoring, AI analytics, like Jamie said. So those of us providing clouds or providing large-scale technology at scale, that we have sort of the ability to do all the monitoring, the alerting, the reaction, the immediate patching, be very responsive. So like Jamie said, it's being responsive when there is an event. But as you move up into, and Mark alluded to this, the SaaS providers that are running on the cloud service providers, all of you running your software out there, have you taken all the steps to secure your data, to secure your application, to secure your models, right? That's what we're talking about here with confidential computing, is that don't just rely on the infrastructure to be secure. Everything above it has to participate in that. And that's really what, our SGX technology, running in Azure cloud, running in IBM cloud, it gives you that hardware trust foundation. And then those software layers then need to participate that. And with our TDX technology coming, which I mentioned, all the virtual environments, the virtual machines in the clouds can then participate at that level as well. So that's the next innovation we're driving at Intel.
Okay. We only have a few minutes left. I just wanted to throw it out for you guys. Do you have any sort of final thoughts on where you would like to see industry cooperation go, where you think it's not going right now? Mark, do you want to start with that?
Sure. I'm really heartened by the formation of the Open Source Security Foundation, which I think is the place for industry to come together and drive forward security standards, as I mentioned, not just for open source security, but everything that OpenSSF is doing applies to closed source security as well. That is a great initiative. I think the other one is the Confidential Computing Consortium that we also founded with Intel and IBM, which is where the industry comes together to drive forward confidential computing technologies. And one of the things that I strongly believe is confidential computing today might be looked at technology that you apply to your most sensitive data and workloads and to apply the multi-party analytics scenarios that I mentioned. But in a few years, it will become ubiquitous as the cost and performance and the software tooling for it matures, and it will just become something that we expect out of all of our software security. In the same way that we expect TLS to protect all our in-transit data, we'll expect confidential computing to protect all of our in-use data as well.
Jimmy? Yeah, I think the only thing I'd add in terms of what Mark said about the layers of innovation and OpenSSF that we're collaborating on is just this education journey that OpenSSF and many of the industry players are also focused on. We have to ensure that all the members of our organizations are sufficiently educated about security and their role in securing the enterprise. And I think there's a great opportunity for communities of individuals in, like the United States, to take advantage of this opportunity called security. So we're really focused on training at all levels, reaching out to historically black colleges and universities, creating apprentice programs so that all of our clients and many of you in the audience can have the right security skills for the future.
Greg?
Yeah, I think, again, Intel is a broad provider of technology across the industry, from, the client to the edge, to the data center, to the cloud. We'll keep just up in the bar, right, in terms of what we can offer. But it's communities like this, right, all of us coming together to then drive that into the application space. I'm most concerned about the edge. It's rapidly expanding. There's a lot of competition. There's a lot of devices being deployed across a lot of processor architectures, many of which don't even have any security hardware features in them. The edge is going to be the new attack surface and the infiltration point back into the cloud. And so we have to really take that seriously as we go forward.
Great, thank you all. Please join me in thanking the panelists for this discussion, and thank you all for your attention.
Thank you, everybody.
Thank you.
Thank you.